Hi everyone. So today is our first class on analog circuit, right? For HAL. So we are supposed to take the entire syllabus of gate examination only. Okay. And in this class, I'm going to just talk about, in our future classes, what are the topic we are going to cover, right? And we will not discuss everything in detail. We will just touch all the topics and solve few problems, right? So mostly in our session, we will be solving um, many questions, okay, related to these topics. So this subject is going to be analog circuit, right? And the topics are like diode circuit, which you might have studied already, right? Where we will talk about application of diodes, okay, clipper, clamper, rectifiers, okay, and then we will discuss bipolar junction transistor and MOSFET amplifiers. So this is just a gate syllabus. My roadmap will be quite different, okay, which will help you to link all the topic, okay, whenever we will start studying the topics. This is just a gate syllabus, okay, where the topics are like diode circuit, okay, and bipolar junction transistor, MOSFET amplifiers, okay, where we will study about biasings, AC coupling, a small signal analysis, frequency response, current mirrors, okay, these are the applications of both bipolar junction transistor and MOSFET as well. Okay, we can design differential amplifiers, and the very important circuit which is most versatile structure, okay, in analog industry is op-amp circuit, right? So op-amp circuit we will discuss, where we will discuss about op-amp amplifiers and its application like summers, differentiator, integrator, active filters, Smith trigger, and so on, okay, and oscillators under different feedbacks, right? Negative feedback and positive feedback, okay, different kind of configuration we will discuss. So this is just a syllabus for HAL as well, okay. So in our first topic, okay, what I'm supposed to start, okay, is that we will first discuss about the amplifier, because if somebody will ask you what basically you study in analog circuit, okay, so most of the classroom you might have seen many starts with diode, right? But in my class I'm going to talk about amplifier modeling, okay. The very first lecture is going to be amplifier modeling, okay. Okay. So this, in this class, I will be only discussing about amplifier modeling, and next will be the very important topic, okay, from which you can expect various questions in HAL examination. That is op-amp, right? Operational amplifier, okay. And the next topic will be diode, okay. Next topic will be what? Diode, okay. Diode application we will say, okay. Diode application. So we'll first discuss about ideal diode, okay, then we will discuss about small signal, part of the diode, okay, how can you realize, uh, right? And then we will discuss about bipolar junction transistor, okay. So let me change the pen here. So then we will discuss about bipolar junction transistor, BJT, and its biasing, and how does it behaves like a amplifier, okay. So all these things, biasing and all, we will discuss. And the very important topic will be in our classroom, that is MOSFET, okay. So we can expect various questions from MOSFET, okay. So what we are not going to discuss in this subject, I will not talk about the device part, right? Device part we are not going to discuss. Only we will discuss the circuit aspects, right? So only we are going to talk about circuits, okay. Like if I'm going to show you this kind of symbol, right? This is a symbol, okay. This is a two terminal device, okay. So only you need to know this is a two terminal device, and it is known as diode, okay. uh, when you apply some voltage across this, so it will help you to get some current, okay. It allows some current to flow, okay. And you need not to get inside what's happening inside this diode. Okay, these are the things which are which is covered in electronic devices. Okay, as far as uh, if you are from electronics and communication, so you study the subject called EDC, right? Okay, so we will make you familiar with the symbols. Okay, this is diode, and if I talk about bipolar junction transistor, so it is a three-terminal device. Okay, so these kind of symbols you must be familiar with. Okay, and whenever we will apply some voltage across it, whenever we will apply some voltage across it, how current flows. Okay, so we will discuss that part only. Okay, the semiconductor physics, okay, which is happening inside these devices, okay, which will be covered in electronic devices. Okay, right. So let me begin the very first topic. Okay, what I have told you is that is amplifier modeling. Okay, amplifier modeling. So my first question is going to be how we model an amplifier, how we model an amplifier. Okay, so if you will be able to understand all the concepts which I'm trying to cover in this session, then you would be able to understand entire analog circuit, right? So I will be taking one important uh, example here, that will be the public address system, right? Public address system. Okay. The very important example I'm going to take here is the public address system. Okay. So in order to understand how we model an amplifier, okay, no matter which device we are going to use, we will use bipolar junction transistor as an amplifier, we will use MOSFET, okay, most transistor as an amplifier. But in this introduction part, we will just see how we can model an amplifier, right? So this is just one application, right? Suppose you want to address some public, in front of you, there are thousands of people, right? And you want your voice to reach to their ears, right? So what you will do here, you will first you will there will be three blocks. Okay, there will be three major blocks. Okay, there will be three major blocks. The first block will be what? The source, right? The source. Okay, and the last block is going to be load. Okay, load, or you can say the speaker, right? Speaker. And the first block is going to be the microphone. Okay, because if there is no microphone, okay, so your voice cannot be picked up by that microphone, and people cannot listen you, right? So this is going to be containing the microphone, right? Microphone here. And suppose there is a microphone and there is this block is absent. Okay, this block is absent, and this block will be what? The amplifier. Okay, this block will be the amplifier. So your voice, okay, which is physical quantity, right? So this microphone will be having what? Transducer inside it, which will convert your voice from non-electrical to electrical quantity. Why we are converting non-electrical quantity to electrical quantity? Because the amplifier is an electrical device which cannot understand non-electrical things, right? So okay, so this microphone will be having transducer. So it will convert into electrical quantity. And what are basic electrical quantity? They are voltage or current, right? So the amplifier will be picking up these voltage and current. Okay, and what is the job of amplifier? We will understand. Okay, wait for the moment. Okay, right. So what is the job of amplifier? How can we model this amplifier? This is the very important question. Most of the candidates do not know, right? Okay. So the microphone will pick up our voice. Okay. And with the help of transducer, we will be able to convert non-electrical quantity into electrical quantity such as voltage or current, right? And this amplifier will give you another voltage or current, right? But what will be happening inside it, we will see in the next slide, right? And this is going to be your speaker. Okay, this is going to be your speaker. If you want to listen your voice back, okay, if you want to listen your voice back, so again you will use speaker, right? And in the speaker, again, there will be transducer inside this speaker so that it will convert electrical.
Sir, please select thick fan, sir.
Okay, sir. This is fine, sir. Okay. Right. So this speaker will be having again one transducer inside it, which will convert.
Yeah, this is fine, sir.
Okay, sir. Thank you. So it will convert electrical quantity into non-electrical quantity because human ear cannot understand electrical thing, right? Okay. So we will see how these three blocks can be modeled. Okay. The first one is what? The first one is microphone, and second one is amplifier, and third one is speaker. Okay. So this is our microphone, and this is amplifier. Okay, which element we are going to use to model these amplifier, these three blocks? Okay, and a speaker. So the microphone can be modeled with the help of what? With the help of two important practical sources, what we know already, right? They are voltage source or current source, right? So the microphone can be modeled. This can be modeled with the help of voltage source, right? Or you can say Thevenin equivalent or Norton equivalents, right? So this microphone can be modeled with the help of voltage sources. I'm talking about practical voltage sources. So you can give the name in the literature as Thevenin equivalent, right, or Norton equivalent sources, and the Norton equivalent. Okay, Norton or this can be Thevenin. Okay, Thevenin equivalent, right, and Norton equivalent here. If your signal is in the form of what? If your signal is in the form of current, so you can use Norton equivalent, right? So depending upon the nature of the input, okay, whether it is voltage or current, you can choose the sources. You can choose the sources, right? You can choose the sources. Okay. So let me go to next slide. So microphone can be modeled, or sources can be modeled, right? With the help of voltage sources such as I told you that this is our voltage source. In the series, there will be one source resistance, okay? If your input signal is in the form of voltage, so you have to use this, right? So this is how we can model microphone. And this is current source, right? So it is also known as Norton equivalent. So in the current source, there will be a resistance parallel, okay? This kind of a model we are going to use, right? So this will be the Thevenin equivalent, this will be the Norton equivalent. So my job is done. We are able to model source, right? We are able to model microphone, right? Now, how can you model the last block, that is speaker, right? How can you model this? So you can model this with the help of simple load resistance RL, right? So this block is only pending here. See, this is amplifier, right? And here we are able to successfully model sources, okay? And this is our load, right?
Sir,
Yes, sir.
sir, why we model load as a resistance? It can be inductive or capacitive in nature, no?
Yeah, it can be. It can be. But the thing is, in future you will come across any parameter which belong to amplifier. Okay, does not depend upon load, right? So you can use anything. Okay, but here, as this is an introductory class, right? So we are going to use load as a resistance only. But in future you will find that depending upon the application, you can use different elements. Okay. But for the present, we will be using load resistor. Okay, so speaker will be modeled as load. Okay.
Okay, sir.
Uh,
Okay, sir.
Depending upon the application, we will see what kind of load we are going to use, right? Uh, yes. So I hope you guys might have understood how we can model the microphone. Okay, microphone can be modeled with the help of Thevenin equivalent and the Norton equivalent. Okay, you might have studied whenever we talk about small signal analysis. So bipolar junction transistor is there, input is suppose voltage and output load is resistance, right? So you model your bipolar junction transistor as using some dependent sources, right? Okay, so what is the reason behind that?
Yes, sir.
Yeah, so we are going to arrive that point. Okay, we are going to talk about that. Okay, so two important points you have to keep in mind. First one is microphone can be modeled with the help of Thevenin equivalent. Okay, Thevenin equivalent. And second important point is if your input is of the form current, right? So you have to use Norton equivalent, or you can say practical current source. Okay, practical current source and load as a resistance symbol. Next. Now the question is, what is an amplifier? What is an amplifier? Suppose there is a microphone, right? And there is no amplifier in front of you. So your voice cannot be, initially whenever you speak something, your voice is at low strength, okay? So if you want to reach your voice to million of people, right? So you need amplifier, okay? Because amplifier is kind of a device which enhances the strength of a signal, which enhances the strength of a signal, okay? Without changing its shape, remember always, okay? Strength of a signal, it will enhance, okay? So your voice will be at high stereo and people will be able to listen you, right? Okay. And if there is no amplifier, then what will happen? Your voice will not be having good strength, so people will not be able to listen you, right? So this is what the importance of amplifier. So this is just a definition of amplifier, what amplifier does, right? It The job of amplifier is what? The amplification of the signal. Okay. Now, how can we mathematically, represent, right? Suppose this is kind of an amplifier, okay, and the input signal is here the voltage, okay. If input signal is voltage, so output signal, suppose output signal is also a voltage, right? We want output signal as a voltage. So amplifier will be having one scalar constant here, K, right? In future you'll find some different dimension of K or dimensionless as well. So you know, output voltage you will wish to get is K times of Vin, right? K times of Vin. So amplification is just if mathematically we say that amplification is what? The multiplication by constant K to the input signal. Okay, suppose input signal is current, right? And output signal is also current. So what we want here is K times of I in, right? Okay. Now you can also take, there are two important, quantity, electrical quantity, voltage or current, right? Suppose in the input there is voltage and in the output there is a current, right? So this will be what? K times V in, okay? So whenever you will try to find the dimension of K here, so K will be what here? I out upon V in, right? I out upon V in. So what is the dimension of K? Can somebody tell me what is the dimension of K here? What is the dimension
So
of K? Anyone?
ohm inverse.
Yes?
So ohm inverse more.
Oh, okay, okay, right, okay. K. Dimension of K is ohm inverse, right? Okay. So can somebody tell me which one is the electrical quantity having the dimension ohm inverse or moho? Like resistance is having the dimension
Yes.
ohm. Yes? Conductance, right?
Yes. Yes.
Yeah, okay. Yeah, conductance. Okay, but you can see here this input signal is being transferred to the output signal, okay, to the output port, right, as a current. Okay, so here the conductance K is having the conductance dimension, okay, conductance. But what kind of conductance this will be? Conductance, right? This will be the transconductance, okay? This will be the transconductance, okay? So whenever input signal is voltage and output signal is current, okay, so that parameter, this K will be having the dimension of transconductance, okay, dimension of transconductance. So this amplifier will be known as transconductance amplifier, right? In the first slide I have discussed here, suppose the input is voltage and the output is also voltage. So can somebody tell me what is the dimension of K here? K will be V out upon V in, right? V out upon V in, okay? So what is the dimension of K? K is not having any dimension, okay? Because both the quantities are voltage.
Yes,
Yeah,
sir.
so it will be represented as AV. So it is also known as voltage gain, okay? Voltage gain, you might have heard voltage gain. And here K equal to what? I out upon I in, okay? This will be represented as what? The current gain. Remember, right? Okay. So there are three kinds of amplifier we have seen till now. Okay, so first one is voltage amplifier, because the input quantity is what voltage and output quantity is voltage. Depending upon that dimension of K, we are able to decide what kind of amplifier is that. Okay, we'll see many examples and we will try to design amplifiers as well. So the moment you will find circuits in the examination, you will be able to tell, okay, this is the transconductance amplifier. Okay, and you will also be able to discuss more parameters regarding like input resistance of the amplifier, output resistance of the amplifier, whether it will be high or low, all these things, right? So we'll see all of them. So this is just an amplifier, okay, and input is voltage, input is current, okay, input is voltage, input is current, right? Here we can write V out, I out. Okay, here we can say I out, and here we can say V out. So I out will be K times of V in, and this is K times of I in. Okay, this is K times of V in, right? And this is K times of I in, right? So depending upon the input and output quantity, right? Depending upon the input and output quantity, you can classify the amplifier. Okay, you can classify the amplifier. So guys, can somebody tell me which element can help us to model an amplifier now, looking at these parameters? Your output is depending upon this, right? So yes, your voice is not audible. Please, yes, Surajit, yeah, tell me. Have you seen
Sir,
any?
can you repeat?
Yes, yes. I'm unable to hear your voice, Surajit. Please. Anyway,
Sir,
so
I'm audible.
are you talking about dependent sources? Yes. So I'm unable to hear your voice. That's why I'm unable to respond. It's okay. So this will be the input now. Okay. So if somebody is going to ask you how many types of amplifiers are there, what you study in analog circuit. So there will be four kind of amplifiers, right? Depending upon input nature of the signal and output nature of the signal. Okay. So how can you get V out equal to K times of V in? How can you get this? V out equal to K times of V in. So you can see here, this V in is what? The controlling parameter, right? Okay. So your output is being controlled by this input voltage. Okay. That's why we are going to model the amplifier with the help of dependent sources. With the help of dependent sources, right? So whenever you study network analysis, okay, so you study about controlled sources, or you can say dependent sources. The major application of dependent sources are to model an amplifier. Remember always, many candidates do not know about it, but if you are from electronics and communication student or electrical engineering, so you must know what is the application of dependent sources. So whenever you will try to model any kind of amplifier, whether it is bipolar junction transistor or op amp or MOSFET, okay, you will always use dependent sources to model an amplifier, right? Okay, so these are the three important major blocks which we are trying to model here, okay? So, so how many kind of, how many types of controlled sources you have seen, Surajit? Can you tell me? Can you tell me how many types of control sources you have seen? So we have seen four kind of control sources. First one is voltage control voltage source, right? And second one is current controlled current source, right? And third one is voltage control current source, and last one is current control voltage source. So these are the four kind of amplifier we have seen already, right? So now we can confidently tell everyone that there are four kind of amplifier which we will study in entire analog circuit, okay? Forget about diode. You will understand diode and everything, right? But if you are able to understand the very first lecture of these sessions, so you will enjoy entire analog circuit, right? So you need not to remember anything, right? You need not to mug up anything. So you will be able to solve the question as well when we will be ready to attack on the question, right? Okay.
Sir,
So the very first, yes, yes, Sujit, yes,
sir, is
yes. Yeah, can you speak I mean using microphone so that we can listen you. I'm unable to listen your voice, so I'm unable to respond to you properly. Uh, right. Anyway, right. So suppose there is a first kind of amplifier that is voltage controlled voltage source, right? So how you basically model these kind of control sources? So you might have seen we use this kind of a shape, right? Diamond shape, okay? Inside this, there is a plus minus, so it is a voltage source, okay? And if there is a K times of V in, so it is the voltage controlled voltage source, right? Anyway, so this is a voltage controlled voltage source. And what we want here is we want V out, right? So directly you can get V out equal to K times of in. That is our requirement. Okay, right. So this is a voltage control voltage source. Second one is what? Current control current source, right? So this is the second block, and our lecture is entirely focused on second block only because first block is very easy, right? We can easily pick up some Thevenin equivalent and connect them. So once all three blocks will be connected, so you would be able to find out voltage gain, current gain, power gain, many things, many parameters, right? Okay, just by applying KVL, KCLs, and voltage division, current division rules. So here this is a current control current source. So we take again one diamond shape, a control source, and we put here one arrow so that it is a current source and K times of I in, right? And what we want here is we want I out. Okay, we want I out, right? So I out will be flowing here like this. Okay, current will be through the branches. Okay, and V out can be measured across that. Okay, right. And third one is going to be, you can say, voltage control current source. So see, this is a current source, right? Why we are saying current source? Because the output quantity is what? The current, that is V out, sorry, I out, and input quantity is what? The voltage, right? So this is going to be our current source, right? And across, see, this will be having K times of V in. And now the current is flowing like this, that is I out. Okay, so I out is going to be what? K times of V in. So K is the transconductance, okay, which is denoted by GM of the transistor, right? GM of the transistor. which we'll talk about when we will discuss about bipolar junction transistor or a MOSFET. Okay, right. And fourth one is going to be if the input is current in nature, so current controlled, and if the output is so this is going to be what? Current controlled voltage source, right? So this is going to be our voltage source and K times of I in. Okay, and here we will try to measure the voltage, that is V out. V out equal to K times of I in. Okay, so if I talk about the dimension of K, so this is V out upon I in, means it will be having the dimension of resistance. Okay, and this resistance will be known as trans resistance. So the current controlled voltage source, if somebody will ask you what is the another name of this amplifier, that is current controlled voltage source, so you can directly say that this is a trans resistance amplifier. Trans resistance amplifier. Okay, so there are four kind of amplifiers. Based on the input and output nature of the signal, we can okay, based on the input and output quantity of the signal, nature of the signal, you can tell, yeah, this is will be the this kind of amplifier, right? Okay, I will summarize as well. So let me combine all these all three major blocks. Okay, the first block is source, second block is amplifier, and third block is load, right? So suppose in this is an amplifier, and the signal will be is of the voltage in nature. So we are going to use suppose first amplifier we are discussing, that is voltage control voltage source amplifier, or we can say voltage amplifier, right? So what are the input and output quantity? Voltage controlled means input is voltage. Voltage source means output is also voltage, right? V out, right? So here we will use Thevenin equivalent. Remember, this is how we will model, and definitely this is a practical voltage source. So we will use resistance in series, and we know that any amplifier is there. Any amplifier is there, it will be having its own input resistance, it will be having its own output resistance. So we will call here this is input resistance of amplifier, right? And how can you model an amplifier? You can model an amplifier with the help of dependent sources. So this is what the K times of Vin, and this Vin will be present here. This Vin will be present here, right? Which is the input of the amplifier. And you know that this dependent source is again the practical. It will be having some output resistance as well. So R out. Okay, this amplifier is having R in. This amplifier is having R out, right? And there is a load connected to it, that is RL. And what we want here is we want V out. Okay, we want V out. So by looking at this from here to here, this is what the source. From here to here, this is what the always amplifier, right? And from here to here, this is the load. Okay, this is the microphone, or sorry, speaker, right? So this is how you can realize any kind of amplifier, guys. In the book called Cedra and Smith, or any book you refer, you will find this kind of equivalence, right? Okay, what you remember always, but needless to remember anything, just understand the things from the application. Okay, so any question will be there, like if they will ask you what is the input resistance of transconductance amplifier, so what you will say, sir? What you will say? You will understand, you will come to know. Okay, wait, I will tell you how you can decide the input resistance and output resistance. Okay, so let me redraw for you again. So this will be the part voltage source, right? And this is the resistance. And this is the amplifier part, that is K times of V in, right? This is RL and this is R out, and this is RS, VS, and This is going to be your V in and this is R in, right? Okay. So let me tell you, from here to here, this is source. From here to here, this is your amplifier. And from here to here, this is your load, right? Okay. Please write properly load, right? And what we want here is we want V out. Okay, Surajit. So are you understanding what I want to tell you basically? Okay. So what we want, yes. So suppose this is a signal, right? Suppose you are speaking something and your signal is in the form of voltage after transducer. So you want, definitely you want this signal to be directly applied to the amplifier. You don't want any drop across this RS, right? Otherwise already your signal is at low strength. Okay, so you want what we want here? We want, you can write here, right? We want V in equal to Vs. What we want? V in equal to Vs. How can you get V in equal to Vs? How can you get V in equal to Vs? Just by keeping this Rs very low compared to R in. Just by keeping this R in very high compared to Rs, right? If Rs is 0, if Rs is short circuited, you can say, or 0 ideally, right? So your entire signal will be across this R in. So now you can decide, if somebody will ask you, what is the input resistance of the voltage amplifier, so you can directly tell that, sir, high, sir. Okay, high, yeah, you can say infinite, sir, ideally. Okay, infinite. How? Because of our requirement. This is our requirement, right? This is our requirement, guys. V in equal to Vs. Okay, now this is what K times of, you can directly say K times of Vs or K times of Vs, you can say, or K times of V in. Now we want K times of what? K times of V in here, right? So you don't want you don't want your signal again to drop across this, right? Otherwise, your job, whatever job of the amplifier was there, it will be in vain, right? So you have to keep this output resistance of this kind of amplifier as low as the, you know, as low. Okay, so you have to keep what you want in the output. You want what? V out equal to K times of V in. So you have to keep RL very high compared to R out. Okay, so practically speaking, input resistance of the amplifier should be high. Okay, practically speaking, input resistance of the voltage amplifier should be high and output resistance of the voltage amplifier should be low. Have you understood, Surajit, what I have, how we decided the input resistance and output resistance practically? Please respond. Hello. Have you understood this?
Yes, sir.
Great.
Yes,
Right. Yeah.
clear.
So see, practically what will happen here is that, suppose if somebody will ask you in the examination also, they will ask you the question in the HAL examination, voltage amplifier, what is R in? What is R out, right? So R in will be high, sir, output, and R out will be low, sir, right? This is the practical, okay, practical resistance, input resistance, output resistance. But if I talk about ideally, so R in should be what? R in should be infinite and R out should be 0. So can you tell me, looking at this input resistance and output resistance, can you tell me any example of voltage amplifier? Okay, any amplifier which you have studied in analog circuit during your GATE preparation or IES preparation, yeah, or in your semesters.
Sir,
Yes.
op-amp.
Op-amp, yes, definitely. Op-amp mimics the property of voltage amplifier. Very great. Okay, so you can directly say that inherently op-amp mimics or behaves like a voltage amplifier. And in network
Sir.
analysis class, whenever they will talk about control sources, so you have to say, sir, these control sources are used in analog circuit, to design amplifiers. Okay, to That is what the major application is, right? Okay, so in the HAL, definitely this kind of question you can expect. Okay, this is voltage amplifier. I'm going to talk about current amplifier. Now you can design yourself current amplifier, right? What is current amplifier? Current amplifier means input will be current, means controlled sources, sorry, current controlled, and output will be again current, so current source you have to use, right? Let me get back to this slide. See, whenever input will be high, remember, whenever input resistance will be high, so for the present you have to keep in mind that this will be voltage controlled. Okay, voltage controlled, right? If input resistance is high, means the nature of the voltage input signal will be voltage. It means voltage controlled. And if output resistance of any amplifier is low, so can you tell me which source is having low series resistance, low resistance? There are two kind of sources, voltage source and current source, right? So which source is having a low resistance? Can you tell me internal low resistance?
So voltage source.
Yes, definitely. That's why we will call always voltage source, right? Now, depending upon the input resistance and output resistance, you can classify the amplifier, right? Again, you can classify the amplifier depending upon what? Based on input resistance and output resistance. Initially, we were trying to classify the amplifier based on the nature of the input of, the amplifiers, right? It's okay. So remember, high means input resistance is high means voltage controlled. Input resistance is low means current controlled, right? Output resistance is low means voltage source. Output resistance is high means output resistance. If any amplifier is having output resistance high, so what kind of source will be that dependent source? That dependent source will be current in nature, right? Please keep in mind. See, now you can directly tell the input resistance and output resistance of current amplifier. Can you tell me? Current controlled. Can you tell me what is going to be the input resistance? What is going to be the output resistance? Can you tell me, please? Yes?
So input impedance high.
No, man. As I told you, current controlled. Okay. In case of, see, if input resistance is high, right? So your nature will be voltage controlled. Okay. Input signal will be always voltage in nature. Remember, slightly contradictory statement, but as we are familiar with the source aspect, right? We know that if voltage source is there, the resistance will be low. Current source is there, the voltage will be the resistance will be high. There is a controlled. Okay, this is not the source. This is a controlling parameter, right? So controlling means you have to exchange, right? Voltage control means high resistance and current control means low resistance. I will talk about how we are directly telling. So R in will be low practically. R out will be what? Can you tell me? Current source now? Yes. R out will be high. Why? Because current source. We know that current
High.
source is
High, sir,
having,
yes.
yes. So please keep in mind this, right? Wait, we will model, right? Can you tell me voltage controlled, voltage controlled current source, right? So what kind of amplifier is this? This is input is what?
Transconductance.
Yes, transconductance, right? This is V in and the output is gonna be I out, right? So the K will be, GM of the transistor, right? Transistor, any kind of transistor. Wait, this is a first class, so I cannot teach everything, right? We need to, get started and keep going. So Veen, so can you tell me what is going to be the input resistance of transconductance amplifier? In the examination, suppose in HL exam, this kind of question is there. Transconductance, okay, transconductance amplifier is having input resistance and output resistance, right? Okay, resistance. Option A, low, high, right? Option B, high, low. C, high, high. Okay, Jose is high, high, right? And low, low. So which option you're going to pick up?
Sir, both high.
Yeah, both high. Matlab, you don't have to mug up, man. You don't have to mug up. So guys,
Yes.
whenever, yeah. So in the any book you might have referred, said Dan Smith, anything, right? So if you study any concept like this, okay, so you would be able to handle any kind of question. Recently in the GATE 2022 as well, you might have seen great questions from analog. So if you have studied like this, so you can answer any question. Otherwise, if you only based on network theory and you think that you know network theory and you can solve analog circuit, so that is the myth, right? Okay.
Yes, sir. Analog weightage is more in this year actually.
Yeah, analog weightage was more, as well as if you study analog conceptually like this, the way I'm trying to present in front of you, so you can keep the analog in your mind till the examination. Otherwise, if you only know KVL, KCL and Ohm's law and you think you can solve questions, so life will be okay.
Yes, sir.
Anyway, so now you can confidently tell anyone that what is the input resistance and output resistance of trans resistance amplifier. Trans resistance amplifier. Trans resistance. Why I'm calling it trans resistance? Because this will be the current control voltage source, right? Means output quantity will be voltage V out and the input quantity is current. Can you tell me?
So both low actually.
Both low actually, yes, very good, low, right? So R out, right? So I think many question you can answer now. 4 to 5 question you can answer from this topic, right? In the feedback amplifier also you might have seen, okay. So this lecture will help you to identify any amplifier will be given, and if there is a feedback connected to it, so you can also tell them, okay, there is a voltage shunt feedback or series shunt feedback, whatever. If you know the nature of the resistances, okay, so we'll talk about that, don't worry. Now,
Sir.
yes. So as I told you that what voltage, the very first example was what voltage control voltage source has the example, that is op amp, right? Can you tell me, Surajit, any example, BJT example, which configuration behaves like a voltage control voltage source, depending upon the input resistance and output resistance? Yes. This is the
Sir,
first.
common emitter.
Common emitter, no man. See, common emitter is having input resistance, output resistance in the intermediate range, right? So if I say that
Yes, yes.
this is a kind of amplifier, suppose any kind of amplifier, right? Okay, so suppose one terminal is common here, right? One terminal is common. Suppose this collector is common, right? And you are applying the voltage here and you're taking the voltage here, right? What kind of configuration is this? Can you tell me? If you are applying voltage here and you are taking the output at emitter terminal, and this guy
Sir,
is
common collector.
common collector, yes, common collector, right? Common collector. So remember always that common collector is having the input resistance in the mega range, right? And output resistance will be in the, okay?
Yes, yes, output resistance
In the
will
ohm
from the
range, you
emitter
can say,
side.
yes. So depending upon the input resistance, output resistance. So common collector is also known as what? The emitter follower, okay. Common collector is
Yes,
also known as
sir.
emitter follower. How we are telling that this is a common collector? How we can say that? How we can decide? See, whenever any candidate pass out, BTech, right? They are not able to identify, in fact, right? Because they know how to find voltage, how to find gain and all, but they don't know what kind of circuit is this, right? So they fail. Okay, they can't get the answer very quickly, right? And if you are able to identify, oh, this is a circuit, right? Oh, this is a clamper circuit. This is a peak detector circuit. So you can answer the question directly, okay? Because you know the job of the peak detector, you know the job of the clamper, right? So identification is also important if you're going to get good rank in GATE examination. Okay. Uh,
Yes.
And if you want to become successful in HAL, so this kind of concepts are required, right? So okay. So in the examination, they will ask you common emitter is having input resistance and output resistance option. Okay. So please, not common emitter, this common collector, or you can say emitter follower. We will understand why we are calling it emitter follower, right? So, Surajit, have you understood this now? So these are the two important
Yes, sir.
examples which we can directly tell, right? Depending upon the input resistance and output resistance, we can tell the examples what we have studied. Can you tell me some common CCCS? Can you help? Can you tell me any important example of CCCS depending upon the input resistance and output resistance?
Sir, common base configuration.
Yeah, great. Very great. Okay, so the important example, see, HAL question will be based on applications. HAL question will be based on your numericals. So any question you will find, we will solve many questions. Okay, don't worry. From the next session, we will use some slide as well, where question will be there. So I will not be able, I do not need to, write everything. I will just solve. So common base amplifier, you can say,
Yes.
right? So common base amplifier will be having what? The input resistance of, you can say in the ohm range, right? So that's why it is known as common collector, and output will be in the, you can say, mega range, right? Mega ohm. Okay, so that will be current source, right? That's why it is known as, if somebody will ask you, common base amplifier is be having as what? Option, common this current control current source, voltage control voltage source. So you have to directly say, sir, this. How you are able to decide? Depending upon the input resistance and output resistance, please. Okay. I hope this is clear. So I have modeled,
Sir.
yes, I have modeled for voltage source. You can model for uh, current controlled current source, right? So current control means input resistance, sorry, input is current only, right? So we will use what? Norton, and resistance will be in the parallel RS, right? This is how we model, okay, without looking at the nodes as well, okay? And you know that any amplifier will be having its own resistance, so please keep happily R in, okay? And what you want here, you want I in, okay? So you have to put arrow here in this branch. Now you have to use what? You have to model the amplifier. So what kind of dependent source you will use? You will use K times of what? K times of I in, right? And where we need to keep the output resistance? Can you tell me? In the series or in the parallel?
Same
Yes,
parallel.
very great. R out here. R out. Very easy, right? In 2014 GATE, one question was there. They gave you input resistance, output resistance. They gave you some these controlling gains and all, right? K values, and they ask you overall gain, right? So you have to quickly draw this circuit like this and apply voltage, voltage division, current division rule, and you can get the answer very quickly, right? And if you don't know how to draw these things, means you will lose 2 marks, okay? But in the examination, in HAL kind of examination, they will ask you only the information regarding input resistance and output resistance. Okay, needless to worry about those big questions, right? And this is RL. So what you want here? You want I out. So now you have to answer me, please. My question will be there. So what do you want exactly? You want what? I in equal to IS. So do you want any current to flow from this circuit, this resistance? Do you
No, sir.
want this? No, no. So can you tell me how I mean how you can keep Rin? Rin must be what? Rin must be what? Low or high? You want entire,
must be low, sir.
yes, as we know that current follows the minimum resistance path.
No
So
resistance,
yes,
yes, sir.
so Rin will be, if Rin is pretty low, so entire current will be flowing like this. So Rin, we can say Rin is far lesser than Rs. This is our requirement, man. Okay, this is my requirement. So In equal to Is, right? That's why I'm calling this is current control. This is current controlled, right? Because Rin is very low. And here, what you want, you don't want anything to be going from this R out, right? So again, R out should be what? High. Okay, R out should be high. Matlab RL must be pretty low. Okay, RL must be
Yes,
pretty
sir.
high. Pretty low, and R out must be high. So now you can directly say, so this is my requirement and I have modeled for you. So from here to here, if somebody will ask you what is this, so source, from here to here, this is amplifier part, from here to here load. Okay, chalo. In the next class I will show you some slides and everything will be drawn properly. And if you are following the lecture from the starting, you will be able to understand all these things, right? Okay.
Yes, sir.
Yes. So,
Sir, at that time, I'm actually asking what is linear amplifier, sir?
okay, what is linear amplifier? Great. Yeah, it is a great question. See, no amplifier you will find in this world as linear, right? We need to make the amplifier linear. And how can we make the amplifier linear? See, any amplifier, you will use some non-linear devices, right? Any amplifier, if you want to design, so you will use what? The non-linear devices. Non-linear devices. Okay. What kind of devices you will use? Bipolar junction transistor, right? Or MOSFET. Okay.
Yes, sir.
Yes. Yes. So without using non-linear devices, you cannot get amplification, right? But if you want these MOSFET and BJT, right? Okay, so what you will do here, you will have to convert these non-linear devices to linear devices, otherwise you will not be able to amplify the signal. So what is the procedure for that? You have studied while preparing for gate examination. Can you tell me how can you convert non-linear devices into linear devices in
Some
the
approximation, sir, using some.
Yes, tell me. You have studied that topic as well, and this time many question was there in the examination. So can you tell me any example of non-linear device? Non-linear, linear element, yes. Any familiar example of linear element?
So resistance.
Yes, resistance, very good. Suppose this is a diode, okay. How can you convert this diode so that it behaves like a resistance? Why? Which procedure you follow? Can you tell me? You
Okay,
have
means using small signal.
Okay, this is the small signal analysis, right? See, you have studied everything, but you don't know, right? Analysis.
No, sir.
See, many how we are calling this signal, this is a small signal. Can you tell me how people call small? Why we are calling it small? Why we can't put a large signal analysis? What is the meaning of small here?
Mm.
Huh?
So because if we apply a large signal, then some distortion may happen
Yes,
or
yes, yes,
anything else.
yes, definitely. We will talk about when we will discuss about small signal analysis. So we will talk about many things, right? So for the present, you will understand reality, okay, behind a small signal, okay. Many people will let you know that there is a 1 million millivolt and all. That's why we call it small and all. But if you want your diode to make the journey from here to here, right? I mean, if you want your signal, right? if you want to keep your signal in the linear region, so what you will do, you will have to go for this analysis, right? We'll see why we are keeping it small or large, you know? And don't worry. So I hope the first part of the question, I mean, wait, let me add some pages. Wait 1 minute. Okay. Yes. So let me summarize here what we have discussed, right? Summary. This will be helpful for HAL examination. Please keep in mind. Okay. So here we will keep the amplifier name, right? Surajit, can you design those two amplifiers, transconductance and trans resistance amplifier? Okay. You would be able to design, right?
Yes.
R in and R out. And here we will talk about some parameters of the amplifier. We'll take some example, numerical example here after this summary, what we have studied. So the first amplifier is what? The voltage control voltage source. Second example is second kind of is current control current source. Third one is voltage control current source, and fourth one is you can keep the name as well, or voltage amplifier or current amplifier, or voltage control can means transconductance amplifier. Okay, these two are important. Okay, in the examination they will ask questions. In the gate also they have asked many times, and in IES many times. Okay, so current control voltage source. So now please shout out. Rn will be what? High. It will be low. It will be low. It is high. Okay, this is high, this is high, this is low, this is low. Now this is just like a binary kind of thing, right? Okay, H L L H
Yes,
H H L L, right? So you don't have to mug up. Okay, parameters may yahan you will get AV. Okay, that is the voltage gain, right? Here you will get AI. Here you will get GM. Here you will get RM. Okay, depending upon the ratios and the dimensions, right? Okay, so can you tell me, Surajit, one example of transconductance amplifier? Hmm?
Transconductance amplifier.
Yes, transconductance amplifier.
No, sir, it's not click actually.
You have studied already transconductance. OTA, have you understood OTA kind of OTA, op, operational transconductance amplifier kind of thing? Okay. So what is happening here? See what is happening here. So using op-amp you can build any kind of amplifier, remember. So this is voltage controlled current source, or I mean this is what? Voltage control
Okay,
current source.
like voltage to current converter or current to voltage converter.
Yes, great. That's what I wanted to make you speak. Great. So please
Okay.
keep in mind this. Okay.
Okay.
So you have studied now. In fact, you have used these kind of op-amp in ADC, analog to digital converter,
Yes, sir.
digital to
Yes.
analog converter, है ना? So this
Yes, sir.
that kind of question was also asked in the examination, right? So matlab, if you know analog properly, in even if you don't know what is happening inside that device, you can model anything, you can design anything, right? And you can answer any kind of question. Chalo. So this is what I want to discuss in amplifier modeling part. And as I said to you that my lecture will be first voltage amplifier, amplifier modeling, right? And then we will discuss my lecture will be what? The amplifier modeling. So this is what I wanted to discuss, okay, in the amplifier modeling part. And second one I will discuss about the op-amp, right? because many questions you will find from the op-amp. And third, as I told you, we will discuss about diode, right? And then we will combine op-amp plus diode, right? Then we will combine op-amp plus diode, and you will understand why we are combining op-amp plus diode, right? You might have seen circuits where diodes are also present, right? Along with the op-amp. Why we do?
Yes, sir.
Yes, why we do that, right? So according to our requirement, we will go ahead. As we know that necessity is the mother of invention, right? So whenever we need to do something, we will introduce that chapter, right? And along with that, we will solve many questions. So let me take one numerical example for realizing gain and all these things, how we can find gain and all. So please write down the question. First question will be what? Find out the voltage gain, the current gain, and the power gain of the current amplifier. Find out voltage gain, okay, voltage gain, current gain, and power gain of the current amplifier, right? Okay. So today my stylus is not working that good, but I will try from the next session, everything will be fine. So find out voltage gain, current gain, and the power gain of the current amplifier. So guys, they have specified current amplifier. What is current amplifier? Current amplifier means what? Current amplifier means current controlled current source. So they will give you in the question, either they can give you what? The circuit itself, okay, circuit they will give you like this. So this is IS. And see, you don't have to use KVL, KCL. You can use directly current division rule, and you can find,
Yeah.
right? This is 1K, this is RS. I mean, this is 10 kilo ohm, right? 10 kilo ohm. Now you can understand why this is 10 kilo ohm, why this is 1 kilo ohm. Okay. Let me remove this part. Yes. This is 10K. Why we are keeping 10K? Why we are keeping 1K? Understanding now?
Yes, sir.
Yes. So please, whenever question is asked in the examination, see the value of resistances as well. Otherwise, you will apply virtual ground concept, and the virtual ground concept will be failed. Why? Because op-amp will be in saturation, right? So because you guys are you directly attacking the question, okay, applying if op-amp is ideal and all those things, right? And you do not see the resistances connected. So that's why a problem will be there, right? And this is having 100 I in, okay. This is the R out, that is 10K, okay. So you have to find I out here, and this is I in, right? I out upon I in will be the current gain. So directly you can find current gain now. Is there any problem? Can you tell me what is I out? By applying current division rule. Current division, you know what? 100 into this current, okay. We want to find 100 into total current, that is 100 I in, right, upon sum of the resistance, right, that is 110, okay. Okay, so this is what the current gain is. Directly you can find the current gain, okay. AI you can directly find.
Yes.
Yes. And how can you find voltage gain? You need to find voltage gain just by finding what? V out. What is V out here? Can you tell me what is V out here? V out will be 10K times I out. And what is I out? I out you will have to calculate, right? Okay, so I out from here you can calculate. This is I out. And how can you find I in? I in can be found out from here, right? So everything you can find
Yes.
out from here. Understand? So voltage gain, current gain, and everything, right? So this will be V in here. Okay, V in you can say. So V in will be I in times. So you can calculate and remember always. Have you noted down this circuit? Just
Yes.
I'm dressing up. Yes, just I'm dressing up, nothing else. So keep in mind a few important points. Keep in mind. Okay, first one is KVL, KCL, right? Current division rule, right? Current division rule. Don't make mistake while applying this, right? Voltage division rule. Okay. All these things while solving the circuit problems, right? Okay, so what you have to do here is first you have to find current gain, then you can find voltage gain, then you can find power gain. What is power gain? What is power gain? Can you tell me what is power gain? Power gain is the product of AV and AI, right? And basically, remember, basically, gain is, of the order of, we can say 10 raised to power, some 10 raised to power 10, 10 raised to power 20, right? So we always express gain, okay? Gain is a large number, you can say large number. So how can you compress any large number to small number? Can you tell me? By taking what? Log. Okay. So we can take log of that. So if there is a current or a voltage gain, right? There is a current or a voltage gain. So what you can do here? There is a current or voltage. You can take 20 log of that voltage gain. You can take 20 log of AI, and if there is a power gain, so what you can say? 10 log of AP. Understand, Surajit? Okay. So this is how we express. So this will be in dB. Okay, dB. Okay, so you can calculate all this quantity. So few important question again I am going to ask you. Sometimes voltage amplifier is known as voltage buffer. Voltage amplifier is known as voltage buffer, right? What is the meaning of voltage buffer? So can you tell me what is the input resistance of voltage buffer? Surajit, are you there? Can you answer? So whatever the input resistance is of voltage amplifier, the same input resistance will be of voltage buffer, right? And voltage buffer is always having the voltage gain as unity, and it will be having current gain high. Remember, right? That's why we will get what? Power gain will be equal to current gain. These informations also you have to keep in mind. Any buffer, whether it is voltage buffer or a current buffer, right? If it is a voltage buffer, so voltage gain will be very, very low, right? Voltage gain will be very, very low. Remember always, voltage gain will be very, very low, and the current gain will be high. Okay, so sometimes people get confused, right? Because overall, what matters for the amplifier is the power gain. Okay. Now, if there is a current buffer, so the voltage gain will be high. Okay, HAL, you can expect question from here as well. And your current gain will be low. Unity, or not low, you can say unity, just say unity. Okay, just remove this low. Okay, next. Are you there, Surajit? Are you understanding what I want to convey here? Oh, okay. So current buffer and all these things you have to keep in mind, right? So this is what I want to discuss in amplifier modeling part. And please keep this in mind. Please keep the application part also in your mind. What is the application of transconductance amplifier and all those things. Okay. So now what we are going to start is the op-amp, right? That is known as operational amplifier, right? We will again brush up regarding this topic. So if you have understood the introduction part, you would be able to understand everything. Right? Op-amp. What is op-amp? What is op-amp? Op-amp means operational amplifier. Operational amplifier. Okay. Operational amplifier. And many questions from there, from this topic will be is expected in the HAL examination. Remember. So the moment you will find the op-amp question now, you will remember me. Dheeraj sir has told, like this. So you would be able to, attack into that question, right? Op-amp. So operational amplifier, we will just discuss various problems. Okay, so before that we need to discuss how, what kind of approach, what are the important topics we will be studying under this category, right? So how what kind of symbol you have seen for the op-amp, right? So this kind of symbol you might have seen. Okay, this kind of symbol, right? So we'll go to next slide. Okay, and we will see here okay, so this is just op-amp. Okay, we need not to go to talk about differential amplifiers and all those number of blocks and all. We will directly take up because we are preparing for HAL, so we need to be very smart. Okay, right. So this is just an op-amp. Remember, this is the sign of the op-amp plus minus. Okay, and if signal is connected to plus terminal, so that terminal is known as what kind of terminal? Can you tell me what is the name of this terminal? What is the name of this terminal? There will be supplies, right? You can BEE, right? And this is the output of the op-amp. Okay, so can you tell me what is the name of this? Suppose you are applying signal like this, and you are applying signal like this, right? And if you are applying input to positive terminal and you're getting output as this, right? So this will be what the positive terminal will be known as non-inverting, right? And this terminal will be known as inverting. Why? Because you will get 180-degree phase shift out of it, right? One invert, yes. So non-inverting and inverting terminals. This is what the book says. This is what the book says. Okay, and what we will say, that is important, right? Please keep in mind that if this is plus and this is minus, okay, this is a op-amp sign, will not get inside the structure of the op-amp. Okay, otherwise we can keep here A and we can keep B, and I can ask you what is the sign of A, what is the sign of B, right? Connecting under negative feedback, okay, under some feedback. Okay, so you will have to find this kind of questions are also asked in the interview. Okay, whenever you go to IITs, right? But for the time being, we are preparing for HAL, so we will directly put plus minus, right? Okay, Bilajin. Yes. Yes, the voice is I'm unable to listen your voice. It's okay. Uh, we will talk about it, right? So your positive terminal, which is known as non-inverting terminal, right? We'll call this is V1 and this is V2. So we'll call it voltage summing node, right? We will call what kind of name we will give? Voltage summing node. Okay. Keep in mind this. Okay, naming voltage summing, and this will be known as current summing node, right? Current summing node. Okay. And the output will be output only, V out. And always keep in mind your output, okay, your output quantity of any amplifier does not depend upon the load resistance. ये बहुत important notes है, आप इसको याद रखना. क्या? Output voltage, right, or current, okay, does not depend upon the load. ये बहुत important है. Okay, this is very important. Okay, so please keep in mind current summing node and voltage summing node. Why we call it current summing and voltage summing, you will come to know, right? So non-inverting means positive sign of the op amp, and negative means negative sign of the op amp, right? I mean inverting. Why we are whenever we apply some signal, okay, and we get some phase inversion, okay, so that is inverting amplifier, right? So now we understood that there are two kind of amplifiers. One is inverting and one will be non-inverting, right? And also the very important, the very first op amp, what we know is the mu A741, right? Mu A741. That was invented by Fairchild, right? Fairchild.
Yes.
Yes. So suppose there is a V1, this is V2, and this is plus minus. So what is the output here? Output will be what? Op amp always takes the difference. Op amp always take the difference of these two input, right? Difference, right? So it has, suppose it has gain A, so A times VD will be the output, right? So you can understand that now looking at V out equal to A times of VD. After all, input is what? The voltage, now you are taking difference V1 minus V2, but they are the voltage only, na? They are the voltages. Output is also voltages. So the op amp is what kind of amplifier? That is voltage control, voltage source. Okay. So you can ideally tell now the parameter like input resistance will be high, input resistance will be high, output resistance will be low for ideal op amp. है ना? In the question they will ask you. Okay. So op amp is having R in infinity, R out, 0. Okay. So please keep these things in mind. Okay. Right. So what is the output of the op amp? Any op amp? What is the output of the op amp? Output of the op amp will be gain times the difference. Output of the op amp will be gain times the difference, right? And what kind of gain this will be? See, if there is this kind of model, or you can say symbol for the op amp is given, and there is no connection between input and output. If there is no connection between input and output, it means that this is an open loop gain. What kind of gain is this? Open loop gain. There is no closed loop. Okay, there is no connection between input and output, right? We can say that this is V out equal to AOL times VD, right? So this is basically a constant. Okay, this is constant. Okay, so your V out is depending upon what? Proportional to VD, right? So if I talk about transfer characteristics, right, in the analog circuit, remember always we will talk about two kind of characteristics, right? One will be current versus voltage, that is IV characteristic. One will be output voltage versus input voltage. So this characteristic is known as what? The transfer characteristic. What is this? Transfer characteristics, right? So op-amp will be having this kind of characteristics, right? Remember, this is a transfer characteristics I am drawing. And remember, op-amp is what kind of amplifier? It is a high gain differential amplifier. Op-amp is what? Op-amp is high gain, ideally high gain differential amplifier. Why we are calling it differential? Because we will take difference of the input. Okay. So if suppose this is a power supply, suppose that is 12 volt and this is minus 12 volt, right? And if the gain is very, very high, okay, and this is your VD and this is your V out. So if the difference is quite small, if the difference is quite small, right? So your op-amp will behave linearly, right? Like this. Okay. And if this V in, okay, is very, very high, okay, or you can say your difference of the input is large, right? So what will happen? Your op-amp will get saturated like this, okay, because, okay, like this, because your output cannot be more than the power supply given. Always keep in mind, if your op-amp is saturated, so answer will be what? Suppose your op-amp is saturated at negative voltage, so answer will be minus 12. Okay, so these concepts are very important. So if difference is small, right, if difference is small, then your op-amp will behave linearly. This is a linear region and this is a saturation region. So we have to always keep in mind that my op-amp should not get saturated. Okay, my op-amp should not get saturated. If it will be saturated, then okay, your all virtual ground concepts and all what you know will be failed. Okay, so this is the transfer characteristic of the op-amp. Transfer. Surajit, have you understood this? Already you know, okay, regarding this. So we'll go ahead. This is
Yes.
a transfer correct. Yes. So keep in mind how we are getting linear region and we are just considering uh, the ideal op-amp. Now you have to keep one note. You can write down if an amplifier works. Okay, if an amplifier works, if an amplifier works with, okay, two supplies, that is positive and negative, with a gain K, right? With a gain K. So in order to avoid clipping, right? In order to avoid clipping of the input signal, right? Clipping clipping of the input signal, swing, you can say swing, right? Input signal swing, you have to keep what? In order to avoid clipping, the input signal swing should be what? Input signal swing should be this. You have in the examination what they will ask. If amplifier works with the two supplies, that is positive and negative, okay, and the gain K is there. So in order to avoid clipping of the input signal, right? So what should be the input signal swing? So input signal swing should be what? Can you tell me? Input signal swing should be minus V by K to plus V by K. Means your input should lie between minus V by K and plus V by K. Okay.
Yes.
Suppose this is K and this is plus V, this is minus V. Okay. And this is your input, right? And if they will ask you what is the range of input, what should be the range of input? Okay, and there is a V out. Okay, V out is given, and your V out should lie between what? Your V out should lie between minus V and plus V. So your V input should lie between, can you tell me? Minus V by K to V by K. Okay, this is how we find it. So please, this is very important. You can expect question from here. That very important condition to avoid clipping of the input signal. Okay.
Can we apply?
Yes. Can you apply?
Sir, can we apply the supply voltage plus VCC and 0 volt to the op amp?
Yes, definitely. See, what you have to do here is suppose this kind you are asking like this, okay? Plus VCC and 0, right? Okay. So depending upon the applications, right? If your virtual ground, if your op amp is not getting saturated, right? All these things we have to maintain, right? So that's why we are preferring here the symmetrical supplies, right? So that we could get the symmetrical output swing like this, okay?
Yes.
Right?
Yes.
This is positive, this is
Sir, in that case, if differential signal is 0, so output is goes in, in saturation, no, sir, in that case.
yes, that's what I'm saying now. See, suppose initially you will, this kind of question also can be asked. Definitely this kind of question also can be asked. Suppose this is plus VC and this is minus VCC and you have changed by mistake this 0, right? So you will get different kind of nature, okay? You will get different kind of output. So you have to be very careful about that, okay? So if you're changing these supplies, so you have to also see the output, you have to also see the input and everything. So you can't directly change the supply directly, right? But this is very important what you are
Okay.
asking for. Okay.
Yes,
So
sir.
yes. So for clipping, to white clipping, you have to keep your input range from minus V by K to V by K. And your question was very good question. Okay. Okay. Nobody thinks like that. Okay. I mean, people get op amp problem and answer the question. That's it. Still, your question, I think, may not have been answered, but I will answer everything in the next class, right? Don't worry. Okay.
Okay, sir.
So remember, Surajit, we will basically talk about three basic modes of operational amplifier. Okay. So note down three basic modes of operations. Three basic modes of operations, right? Of an op amp. Means whatever problem you will get in the examination, you will get three basic modes. Okay. You will get three basic modes, right? The first mode will be negative feedback mode. Second will be positive feedback mode, and third will be open loop, right? So three basic modes we will see, three basic modes, and we will solve many problems after discussing all these concepts. We'll solve many problems, don't worry. Today only we will take up many problems. So the first under negative feedback mode, remember, under negative feedback mode, what is feedback, you know, right? If some part of the output is fed back to the input, right? That's why we call it feedback, okay? And if there is no connection, then it's okay. So under negative feedback, you will study, you will take up op amp as, linear and non-linear, right? You will perform linear operations, you will perform non-linear operations, right? After all, op amp is used for performing different operations, right? So under linear operations, you will try to study four kind of amplifiers, right? What are the four kind of amplifier? Can you tell me? VCVS?
So error subtractor in Ocha.
Array
Okay.
amplifier I'm asking. They are the applications,
Yes, sir.
subtractor and all.
Yes.
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 CCCS, okay. Linear operation, right? VCCS and CCVS. Yes. This is 4 kind of amplifier. Then you will study about application, that is adder, subtractor, and the very important, which will be asked in your
Integrated
HL
differential.
examination, instrumentation amplifier. Instrumentation amplifier. You will come to know what is the need of instrumentation amplifier, right? In my lecture only. Can you tell me what is the need of instrumentation amplifier?
So
And
to make the input impedance low.
what?
To make the input impedance low.
Oh, to make the input
Okay.
input. Oh, then what kind of advantage you will get by making that? Please find out that answer, right? Instrumentation amplifier, right? So non-linear operations means rectifier. See what your what your diode can do, then op-amp can also do, right? Rectifier, peak detector, right? Peak detector. So to study this part, we need to introduce after this what? We need to introduce what? Can you tell me? After studying linear operation under negative feedback mode, we need to introduce one important topic, that is diode, right? So diode जैसे आ जाएगा, so we will combine op-amp and diode and we will study about non-linear operations. Peak detector, clipper, है ना? Clamper and log amplifier and exponential. So whenever question will be given, they might ask you what kind of amplifier is this? Is it a log amplifier? Is it a exponential amplifier? So depending upon the nature of the output, you can decide. Okay. Okay, Surajit. Second mode you will study
Yes.
about the positive. Yes. Second mode will be the open loop mode. If the op-amp is open loop, right? So it will behave simply like a comparator. It will behave like a comparator, right? Comparator, or you can say detector. So where do you use this detector? Can you tell me where do you use this detector? Have you used detector anywhere to detect the signal at the output at the receiver in the digital communication, right?
Yes.
You have used, you have put
Yes.
some match filter, then some threshold, right? And you have detected. So open loop.
This devices.
Yes. And last mode will be the positive feedback mode. So what are the topic you're going to study under positive feedback mode? Like Smith trigger, right? Second, you will study about multi vibrators. So multi vibrators. Question will be definitely there, right? Multi vibrators. Okay, I stable, bistable, okay, and all those things, right? Multi vibrator, mono stable, right? Because in the vending machine, you might have seen whenever you want coffee, so according to the size of the cup, your vending machine works, right? So it will work for some 10 seconds, right? Okay, so you will get your coffee mug will be filled. Suppose this is a vending machine and there is a coffee, right? So you will put some, you will give some triggering, right? So it will work for 10 seconds so that, things will be okay. Your cup will be filled. So mono stable. Understand? So we'll study multi-vibrator and everything. So now the very important, information which you need to keep in mind, that in order to solve, right? In order to solve circuit involving negative feedback, in order to solve circuit involving negative feedback, okay, in order to solve circuit involving negative feedback, you have to keep in mind two things. Okay, negative feedback, two important assumptions you have to keep in mind. Okay, keep in mind two important assumptions, right? Two important realistic assumption, you can say, or assumptions. Number one, please, Surajit, please keep in mind this, right? So number one, you have to keep in mind that, let me change the color here. So the V inverting equal to V non-inverting, right? Okay. And second important assumption you have to keep in mind that op-amp does not take any current, right? Op-amp draws no current. Okay, op-amp draws no current, remember.
Okay.
This condition, sometimes people call it virtual short, okay. Sometimes we call it virtual ground as well, right? So you don't have to worry about that. Remember always, whenever you are applying virtual ground concept, or you can say virtual short concepts, in V inverting and V non-inverting is same, potential at V inverting and potential at non-inverting is same. So remember that your output should not be saturated. If your output is saturated, means that assumption is wrong, remember. Okay. Okay. So these are the two important assumptions you have to keep in mind. Why op-amp does not take current? Can you tell me?
Same input very high.
Yes, input resistance is very high. हाँ. चलो ठीक है, तो let us design very first amplifier using op-amp, that is voltage amplifier. That is voltage amplifier. And voltage amplifier is also known as, or the non-inverting amplifier. Non-inverting amplifier. Voltage amplifier is also known as the non-inverting amplifier, or we call it VC VS. ठीक है. अब आपको you have to design yourself what kind of voltage amplifier या non-inverting amplifier using op-amp, right? So let us design and we will solve questions followed by that. ठीक है. So yes, so this is op-amp, right? This is op-amp and there is a minus sign, there is a plus sign. Now you have to tell me where we have to apply voltage input and okay. So suppose this is resistance, okay, some resistance, feedback resistance we call it, okay, right, and this is the R1, okay. Now can you tell me where we need to apply the input signal, as this is a voltage amplifier and non-inverting, right? Here we need to apply here, right? Need to apply input here, V in, right? So this must be grounded, okay. If we are applying signal at non-inverting amplifier, non-inverting terminal, so this must be grounded, okay. This must be grounded. Now we have also told you that, I have told you that this is known as what? This is known as voltage summing node. This is known as voltage summing node, right? So the nature will be what? Voltage only, okay. Here you can connect many voltage sources. Here you can connect many voltage sources, right? So here it is V in, okay. Here it is V in. This is VRF and here will be V out, right? Okay. Here you can keep RL, no problem, but your output, if you are measuring the voltage across RL, so your RL output will not depend upon load resistance. Now, can you tell me the output of this op-amp? See, op-amp we are considering is ideal. Ideal का मतलब क्या है? The gain is very high. Gain is very high. Okay, the gain is very high, and I have told you two assumptions. So this Vin will be here, right? This Vin will be here, and current will not be taken by the op-amp. Okay, op-amp will not draw any current, right? Understood this, Surajit? Okay. So if there is no current flowing through this, so this and this resistance are in what? This resistance and this resistance are in series, right? Am I correct or not? So this is the voltage here, V out, right? So let me draw this separate resistances. So there is RF, okay, and there is V out, and there is R1, you can say, right? And this voltage V in is across this R1, right? You can say voltage is across this V, okay, this R1. So can you find what is the V in here? Can you find what is V in? By voltage division rule, okay. What is in here? V out R1 upon R1 plus RF, right? So can you find V out upon V in? Because that is the non-inverting amplifier, so it will give you 1 plus RF by R1, right? So you have got the gain of non-inverting amplifier just by applying what? The voltage division rule. What you have applied here? The voltage division rule. Have you understood this, Surajit? You need not to apply KCL. Yes, KCL at this point. You need not to apply. You can solve this by applying KCL as well, but you can directly write the gain by applying voltage division rule, right? So why to go for two steps process, right? If you are getting answer in one step, okay? Understand? Right. So this is a method one. This is the method one. What I follow in the examination directly. Okay. Why I have put these two resistances in series? Because the op-amp does not take any current. So these two resistances are same, right? So there's no mistake at all. Have you understood this? And one more important information you have to keep in mind that you can't apply KCL at each node of this op-amp, right? So can you apply KCL at this point? Can we apply KCL here? Surajit, can we apply KCL? No, because current is 0 here, right? And suppose some current is coming here. So, KCL will be violated. So we can't apply KCL at this point. We can we apply KCL at this point? So you know that op-amp current is unknown. I is unknown here, right? Okay. So, okay, some current is flowing here, some current is flowing here, but this current is unknown. So we can't apply KCL at this point. We can apply KCL at this point only, right? Because this and this current will be same, right? Output incoming current and outgoing current will be same at this node. So we can apply KCL at this point. So remember, KCL fails at different node of the op-amp. Okay, so you have to be very careful. So at this point, you can apply KCL and get the gain. Have you understood this? Let me take one numerical examples of voltage amplifier or non-inverting amplifier. So write down, find out the gain, find out the output, find out the V out. Suppose this is the circuit. Now this is 0.3 sine T, okay? And you have to see the resistance value as well, right? You have to see the resistance value. This is given as 1K and this is given as 9K. So can you answer this question very quickly? I think anyone can answer. If you don't know the gain of non-inverting amplifier, you can apply voltage division rule. Okay. And op-amp is ideal. In the examination, they will mention. आइडियल op amp का मतलब क्या होता है कि गेन इज हाई, द गेन इज हाई, these 2 points will be at same potential. Okay, so see, so directly we can write here this will be 0.3 sin t, right? So you know current will be same here, so voltage division rule. So V out equal to what, or you can say V out equal to 1 plus RF. RF is 9 upon 1. Okay, KK gone, and this is 0.3 sin t. Okay, so this is what the 3 sin t. So this is a voltage amplifier. Understand? You can apply. You see, you can apply KCL. I'm not saying don't apply KCL. Whatever method you know, just my job is to tell you some new methods so that you can minimize the time of solving the questions, and how we approach the question is very important. So if somebody will ask you, can you draw the non-inverting amplifier? So you can draw easily, right? If output quantity is voltage, so directly take one wire, okay, and connect to the negative terminal of the op amp, right? So that you will get you know voltage controlled and voltage source. Now, next question. Next kind of amplifier, in fact, we will take second kind of amplifier is what? And then we will end up the session, right? So the inverting amplifier, inverting amplifier. What is the name of inverting amplifier? You can say inverting amplifier is also known as current controlled voltage source, current controlled voltage source, or we call it trans resistance amplifier, trans resistance amplifier. So tomorrow we will solve many questions, PYQs, and so don't worry at all. Just remember these methods, right? So inverting amplifier or current controlled. So you can see input is what the current control means, I in. Output is what the voltage, V out. So simply you can take the feedback from output. But now you have to keep in mind while drawing the circuit. So see, this is the inverting amplifier or trans resistance. Inverting means where we need to apply the input. We need to apply the input at where? At, this is what the input. This is I in, sorry. This is I in, right? And this is R in. Okay, and here this terminal should be grounded because this is a inverting amplifier, so we are connecting input to the inverting terminal, and there is a feedback, direct feedback. Okay, directly we are connecting to the output. Why? Because the output is voltage source. Okay, so don't connect, don't put any don't take this feedback through RL, directly take the feedback from the voltage node, this node, this is RF, right? So this is the inverting amplifier. Guys, as you know that from the virtual ground concept, you can say virtual ground concept, if op amp is ideal, so this potential and this potential will be same. This is 0 volt and this is 0 volt, right? Same. So, you know, 0 volt will be here. So, you know, it has no significance. Whether you connect R in or you do not connect R in, no significance is there, right? So this current will be flowing directly to, through this. So there will be I in, and this is I in. Why? Because op amp does not take any current. So the current will be flowing through this RF. So the voltage drop will be here. What will be the voltage drop? R in, I in times RF. Okay. So now you can compute the voltage. How you can compute the voltage, output voltage? Just by applying one KVL. So see, you are applying, so you have to take plus here. So plus I in times RF and plus V out equal to 0, right? So V out equal to what? I in RF, okay, minus. So as we know that the dimension will be what? V out upon RF, means, sorry, V out upon I in minus RF. Okay. Understood? So this is a trans resistance amplifier, and this is also known as inverting amplifier. Why? Because the input is connected to negative terminal, right? Now there might be one question in your mind. How can we get the voltage gain of this amplifier? How can we get the current gain of this amplifier, right? All these things. So guys, remember that this is, grounded, okay? So if we are going to put voltage source here, right, V in, okay, and if we are putting R in here, right? So is there any problem? Is there any problem? V out. This is RS. Okay. See, after all, this is a voltage source. It's okay, but it is only giving you the current, right? It is giving you the current. How? Suppose this is 0 volt, this is 0 volt, right? So this will give you the current here, and the current will be I in, right? So this is a voltage source, but okay, it behaves like a constant current source. It behaves like a constant current source. Constant current source. Okay. These concept will be used, you know, to design integrator op amp. Okay, integrator op amp and all. Remember. So constant current source. How? Because 0 volt is there, so I in will be what? V in by R in. You can't change current now. So what we are doing here, we are programming the current into the op amp. Okay, yes. Now you can apply KCL at this point, 0 volt, right? So you can say this is incoming current, this is outgoing current. So we can apply KCL at the 0 volt node. Okay. Apply KCL at 0 volt node, please. 0 वोल्ट नोड में केसीएल लगा दीजिए, क्या हो जाएगा? इनकमिंग करंट इक्वल टू आउटगोइंग करंट, so V in minus 0 by R in, 0 minus V out upon RF. What is V in by R in? V in by V out equal to minus RF by R in. Surajit, have you understood this? The voltage gain of inverting amplifier.
Yes, sir.
So now
So
you are able to
out by
understand.
V, no?
RF by R in. Yes. Sorry. Yes. V out by V in. Yes. Very good. Just let me erase this. Very good. V out by V in. Okay. This is what the answer is, right? So whenever question will be there, see, if somebody will ask you, how can you make the constant current source, right? So what you will do using op amp, what you will do under inverting mode configuration, okay? You have to keep non-inverting as a ground, and apply voltage in series with the resistance, so that will we have like a, okay, समझ आया क्या ये वाला क्वेश्चन जो okay? So yeah, so can you answer one question please, quickly, then we will end up the session here. So tell me what is the output of the op amp, okay, and consider the op amp is ideal. You have to answer this. So this is 2 volt, and this guy is grounded, 5K, right? And tell me what kind of amplifier is this by looking at circuit 3. Tell me output, jaldi se bataiye. V out without using pen and paper. Answer please. Surajit, are you there? See, this is inverting amplifier. So the answer will be what? 2 times of 1 plus 3 by 5. Okay, so V out will be what?
Yes, sir.
Directly you can identify. So 2 times of 5 plus 1, that is 8 by 5, means 16 by 5. Answer. Okay. This is how you can get the answer, right? Second question. This is how I solve the question, right? This is 2 sine t. This is 1k, and here this is what? The 2k, right? What is V out here? Without touching pen and paper. Without touching pen and paper.
Yes.
So the V out will be what? V out will be minus 2 by into 2 sine t, right? So this is going to be what? Minus 4 sine t. You can also find current and everything, right? Okay, so this is how we find out. Okay, and one more question if you want to take. So third question will be that is going to be the last question. So they might ask you this kind of, if they will introduce more complexity. So this is grounded. Whenever you will see the question now, you will always recall Dheeraj sir, right? I mean, what sir has told, 2 sine t and 1k, and this is 2k, right? And do you need KCL, KVL, and Ohm's law? All these things. If you love analog, right? So suppose they will ask you the question, what they will ask you, what is the output of the output current of the op amp, right? This I out. This kind of question has been asked in GATE as well, right? So we solve this question in a second, right? As we know that this guy is what? The current, right? Current. This current will flow here because 0 volt now. So this is a current. How much current is there? 2 milliampere. Okay, 2 milliampere sine t. Hai. And this 2 milliampere will be flowing here. So you know the current here. You need to find the voltage. How can you find the voltage? V out. V out will be minus RF by R1. कितना हो जाएगा ये? Minus 2 times 2 sine t, right? So don't get confused. That is 4 sine t. Okay. So you know the current. How much? 2 milliampere sine t. You know the current through this now. What is the current here? Minus 4 upon 3k sine t. Means this k will go up. So it will be 4 by 3 milliampere sine t. Okay. So now you can apply at this point the KCL, right? You can apply KCL. Why? Because you know this current. You know this current. You know this current. In the earlier slides, we were saying that we can't apply KCL at output, right? And if we are not able to apply KCL at output, then we need to go for virtual ground concept or virtual short concept, right? Anyway, so now you can find the answer, right? So this is coming current I naught plus this equal to this. Okay, so you can answer this question easily. Surajit, have you understood this now? So you will get I out as minus 10 by 3 sine t milliampere. So this is what I wanted to discuss and for today's class. Okay. Thank you so much. Okay. Today we tried to give you more content on amplifier modeling, right? In the future class, we will use some slide as well so that you will understand more properly. We'll try to present everything properly, right? And we'll try to manage this stylus as well. This stylus is not properly. Okay, so have you understood, Surajit, regarding amplifier modeling and these questions, op-amp questions, how we have to tackle? Okay. So tomorrow we will take many problems based on op-amp and then we'll start diode as well. Thank you so much. We'll meet tomorrow. Thank you.